If you take AWS for Amazon, I think it is 17% of their revenue, but 69% of their profit.
Yes. AWS is their profit-making machine. Yeah.
AI is also changing the dynamics. So the three guys who dominate cloud, right, globally, AWS, Azure, which is Microsoft, and Google. AWS has lost the race. I mean, they're not there.
Really?
We are raising about 400 million now, primarily for.
Raj, welcome to the Founder Thesis podcast. I want to understand your pre-entrepreneurial journey.
Basically, I'm an engineer. I passed out in 91, but I started this entrepreneurial journey in 90. So it's quite a long time back, but kind of in my third year, I kind of my cousin was building some PCs, so I kind of learned it. We did some good stuff. I mean, we did some antivirus cards and a whole lot of things. But running a business is much more than just knowing how to build products. I mean, so kind of messed up. I had to stop doing it because and I actually ended with a debt of about 1.5 lakhs. At that time, it was a lot of money. I mean, and so I started working at PCL, Pertec Computers. That's how we. I mean, I started building a career in PC industry. There were not too many servers at that time. Same PC board in a larger cabinet was a server. I mean, that's how we were doing it. And from PCL, I got an opportunity to get into Dell. So Dell was a liaison office, so I was second employee, and we kind of built Dell from scratch in India. We took Dell Direct, we set up a local entity, and post Dell, I joined Microsoft. I was running Windows for
How, how
SAARC
many
countries.
how many years in each role? So Dell, you were doing like sales basically.
Yeah, it was all sales. I mean, we were four of us plus one country manager in India, and I was handling the southern region part of it. I mean, and uh, one was a coordinator. I mean, and three of us sales guys. That's how we started Dell. I mean, today Dell is thousands of people. In Dell, I spent 5 years. I think apart from being successful as a salesperson, Dell gave me an opportunity to run server and storage business in India, and that's how I started getting into servers and started playing with bigger machines. Then we got an opportunity to see what was happening in Malaysia. Dell was making PCs in Malaysia. We also saw an opportunity for Malaysia to take some back-end support, which we wanted to, which I thought was an opportunity to fight back and get something into India. So me and a couple of others in US, we actually worked hard for about a couple of years and brought first 84 people headcount into India for global backend support. Today, I mean, when I quit Dell, I mean, it was about 8,000, but finally it grew to about 16,000 people. So India started delivering global support. So I think apart from the thousands of servers we sold, I think what is more, satisfying is the work we did in getting backend into India. And from Dell, I moved to Microsoft. I was running Windows for SAARC countries, so it was a short stint. I really couldn't do much in Microsoft because Microsoft is Windows runs on its own. I mean, an individual cannot really make a dent in it. So we thought. So I thought it is very. I mean, I felt suffocated because I couldn't really do much. I mean, it moves on its own, and it's a fairly large business, but it moves on its own, and I was not making an impact.
Like you
So
don't need to sell Windows; it sells on its own. Because I mean,
yeah,
by
um,
default, there is no other choice.
no, our job was actually at that time primarily to convert pirated Windows to a licensed Windows. I mean, so there was so Windows was already being used. I mean, it's all about how do we push a legal version into it. Desktops and all mostly were pre-bundled at the OEM, but servers was a major challenge, and we did some work around that. From Microsoft, I perhaps would have worked in Intel, but
In Dell also, you were on the server side of the business, like selling servers?
yeah, initially I did PCs, and then Dell launched servers. I mean, so I launched servers in Dell in India, and at that time Dell kind of aligned with EMC for storage. So servers and storage is what I was taking care for the country.
Now, very basic question. What is the difference between a PC and a server?
I mean, today there's a lot of difference. At that time, there was not too much of a difference. But I think one of the options that we had was we could put multiple processors in a server so that you can actually run much more in terms of compute than a desktop could do. What we had in Dell as a portfolio, we had four processors as the Mac Peak offering. I mean, four server processors in one box. There were, of course, other machines from Unisys and all which would go to 32, but primarily, we had a very good machine. I sold my first four processor machines to Wipro actually to run their exchange, email, and all that stuff. So it's basically lots of more storage, more memory, and more compute is what a server is.
Okay, and it's like the difference between a car and a 16-wheel truck, for example.
Yeah, it is like that. There are a few more things in server. You avoid certain more number of single point failures. Like you have two power supplies at a minimum. The newer servers, I mean, that we are doing now, GPU ones have got six power supplies. Normally PCs and laptops have one. So that's there. I mean, so it's basically built for. Um, Typically, a server once it's switched on, it is never switched off in its lifetime.
Uh, doesn't that cause a lot of heat? What? How do you manage the heat?
It is. I mean, so the problems when I was in Dell were actually pretty small in terms of heat. I mean, but these days it is a massive issue because servers consume up to 10 kilowatts by themselves. I mean, so that's like a geyser sitting there. And there are two ways you can cool a server. Either you put at least 18 fans in it, which run at very high speed and make a lot of racket. And the other way to do it is you use liquid cooling. So we are deploying liquid cooling for managing the heat. So yeah, you can cool it with air, which is inefficient, or you could cool it with liquid.
So, a server is something that is typically bought off the shelf. Like you would just go to a Dell and place an order and you get a server, or is it custom built? Like, for example, you said that you decided to deploy liquid cooling. So that means you bought a model which had liquid cooling, or is this like a custom built server?
Oh no, there are a lot of config. I mean, a lot of choices on the server. So today, processors come with up to 192 cores. I mean, that is 192 mini processors in one physical die, right? I
A
mean,
processor is like, say, like an Intel chip would be a processor. Okay.
so what happened was processors started as one unit, but as people wanted more compute, they started putting multiple units in one die. Die is just a packaging, and you call that whole die as a processor, and each processor inside is a core. So today you get multiple processors in one die, so you call it a processor with multiple cores. The best ones that are available today, you can get 192 cores, that is 192 processors in one packaging, and you can put two of them in one server. So you can have 350 plus. I mean, so we have a lot of processing power available on processors today.
For a desktop, for like a laptop, how many? cores are there? Like a comparative one?
So you can buy up to, so it's all about heat, right? I mean, so typically when it's a laptop, I mean, normally you buy 2 core. There are models available with 4 cores, but the more cores you buy, I mean, you will run out of your battery much faster. I mean, so it's
Okay. Okay. So coming back to my question, are these custom built or off the shelf? Like,
Yeah, so in a server, so you can start from, let's say, 8 cores to 192 cores. So you have lots of options. So first choice you will make is the number of cores you want. Typically, you make that decision based on the application you are running, and then you have a choice of memory. Like today, you can go up to 6 TB of memory, which is typically 6,000 GB of memory.
this
Normally, our
memory is
laptop
the RAM or the ROM? Like, there are two types of
RAM,
memory.
RAM, yeah,
RAM of
RAM,
6 TB. Wow,
yeah.
phenomenal. So, I mean, my
Yeah,
laptop probably has like 16 GB. So compared to that, 6 TB
yeah,
RAM is
16
crazy.
GB is good.
Yeah,
Most laptops have 8 GB, man, and
right.
that's how. Uh,
Hmm.
so you go up to 6 TB. We don't do 6 TB mostly. I mean, we do between 2 to 3 TB, because the more denser the memory is, the more expensive it is. So you want to balance out the cost versus performance. So you kind of buy that. Then the third level is number of disks that you can put. Most of the servers today you can put 24 disks in it. So just to give you a perspective, we buy 15 TB drives now, which are NVMe's, 15 into
What is
24.
MEME?
So NVMe is non-volatile memory. It is so if you remember earlier, there were hard drives where there was a magnetic disk which was rotating. They are not so reliable and they are slow. Now that has been replaced with memory itself. Why is it non-volatile? RAM is volatile. It will forget if you switch off the power, whereas this non-volatile memory doesn't switch off. I mean, so
This is also called SSD, right? Solid state something. I don't know what the
yeah,
D is for.
SSD was the one generation previous,
Uh,
and now it is, yeah, it is solid state disk only now, but NVMe is how it is done today.
okay,
Yeah.
fascinating. Okay.
So just to give you a perspective, I mean, you do 15 into 24, about, let's say, 360, a 360 GB of TB of memory in it. So and that fits into about 3.5 inches in a rack. So if you take my monitor size, you can put a petabyte of storage in servers these days. You have much bigger options available, but this is what we play with. So there's a lot of configuration.
1 petabyte is 100 GB,
1000 TB.
1000 GB. So
TB.
1000 TB. Okay, 1000 TB. Wow.
So
Okay.
1000 GB is 1 TB,
Hmm.
and then
1000
1000
TB.
TB is 1 petabyte.
Okay. 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 Crazy. Hmm. Okay.
We have 140 petabytes in production.
Okay. 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 Got it. So yeah. So you make these choices. Then what?
You make the choices, then you also make a choice on what type of resiliency you want. There is something called RAID. I mean, where basically, do you keep 2 copies of the data that is there, or you put a parity and then try and recover in case of disk failures? That's another choice you make, and then you make a choice on network. Typically, I mean, our laptops and desktops have got 1 gig network. We are now for AI, we're using 400 Gbps network.
Okay. What is RAID? You said RAID is for resiliency. What does it mean?
It's basically what it does is that it's a controller which sits before the above the disks, between the memory and the disk. And what it does is, when you're writing, you have multiple choices. I mean, you can configure it to write twice in 2 sets of disks. Let's say you have 24 disks, 12 being as one set and another 12 being as one set. Then if you lose one of the disks, I mean, you still have your data intact. There are other ways of doing it. That's called RAID 10. I mean, there is better efficiency ways of doing it, where you generate a parity bit. so that you recover the data in case of failure of a disk through parity. So these are some techniques that you use. Normally, the best way to do it is, RAID 10, where you maintain two copies.
What do you mean recover through parity? What is a parity bit?
So what happens in
Image
parity?
of the disk.
No. It is just a mathematical calculation. So basically, when you count all the bits, I mean, whether it's an odd or an even. So if you lose one disk, I mean, and if it was earlier even, then you lose one disk, then you know what to put back because it is. If it is odd, I mean, you add one so that it becomes even. So it kind of mathematically calculates what is missing.
Okay, so it's an algorithmic way of creating a backup of the data in such a way that it's more efficient than 100% duplication.
Yeah.
Like
So I
the
mean,
crude way would be 100% duplication. Everything exists in two copies.
no, that's the
The
best way
advanced way.
because you see, in your laptop you have one disk. If it fails, I mean, you lose your data. That's why you keep a backup somewhere in iCloud or whatever. But yeah, in a server, I mean, you need to have much more. You have two sets of data. That's the best way to do it. If the data is not very critical, you can do this parity based thing. But the problem with parity thing is if you lose two disks, you can't recover.
Hmm. Okay. Right.
Whereas in a
It's like
two copy,
90%
yeah,
safe, if not 99% safe, something like that.
yeah, yeah,
The closer you want to get to 99% safety, the more you have to do the brute
yeah,
force way. Okay. Got it.
yeah.
Okay. Understood. Right. Okay. So you make
No,
these choices.
actually,
Yeah.
yeah, you make these choices, and then you have a server operating system. That's another choice you make. Whether you make a line. Typically, large systems are run on Linux. Some enterprise applications run on Windows, but most of our large customers, like Election Commission and all, run on Linux only. And Linux is free to use, and it powers most of the internet. I mean, like 99% of the internet.
Okay. Uh, Why did okay? Let's finish this theme first. Then I'll ask you about Linux. Yeah. Okay. So you decide which operating system. Then
Yeah, and then the server is deployed and configured.
no,
Then you can put
so
any application.
no, but you get a vendor to build this for you, or like this is just you go on a website, click, and order, and Dell delivers. Like,
In India, very rarely people buy it online. You can do, but typically people rarely buy online. So Dell would build the full configuration, or an HP would build the full configuration, and that full configuration is tested. So they will be, depending on your quality norms. I mean, it's tested for 3 days or something. So it's called burn and test. I mean, so you see whether any components fail once it's all put together. If it doesn't fail, it comes out of the quality control, gets packaged and shipped. Today, these kind of servers are made in India. The GPU servers are not made in India, but regular application servers are made in India. When I was in Dell, it was made in Penang, Malaysia.
okay, when you say made in India, is that assembled in India, or I'm sure the chips would
Um,
not be like
yeah.
Taiwan makes all the
So
chips, right?
no, if you take any of the OEMs, I mean, the processor comes from an Intel or an AMD. The memory comes from likes of Samsung, Micron, or multiple others, Hynix. There are a few options. This like we buy from Micron or Samsung or Western Digital. The typically motherboard is built by one of the big guys who builds motherboards. I mean, so it's not. It's made for a spec for an OEM, but it is not really a high value item. But it's not made by the OEMs at all. And there is a chassis, which is the aluminum piece, which houses the whole thing. So in a factory, typically people put all these together. They take a chassis, put the board, put processor, memory, and so I mean these things together, and then you just put them together. So to answer your question, yeah, it is assembly only.
And the players who sell servers in India, these are like domestic companies or global companies? Like, whom do you typically buy from then?
No, it's all Indian. So when I was in PCL, there was PCL, Wipro, there was HCL, there was, I mean, these were the domestic companies which were actually majority of the market. When I joined Dell, the PCs became twice as expensive. I mean, and I never thought MNCs would dominate. But if you see today, no Indian manufacturer makes PCs and servers. It's all fully dominated by global players. I mean, that market has got wiped out. I mean, there is today some people are trying to come up, but I don't think you can match the volumes that these large players produce. And you don't produce in volume, you don't get the cost benefit, so you might kind of miss out. Um, but that entire industry died. So they just vanished. And from a point where I thought people would not be able to buy these MNC PCs, I was surprised to know that, even in MNCs, there were a lot of turmoil. I mean, when I was in Dell, there was a company called Compaq, which was the largest provider, and Compaq died. I mean, so it's doesn't
Yeah,
exist.
HP acquired,
Yeah.
right? Okay, okay. So the server business is essentially about volumes, like to negotiate best prices for all of these components, like the hard disk, etc. You need to have volumes, otherwise you will be priced out of the market. So the more volumes you have, the better price you are able to offer to your buyers eventually. And people who buy servers are typically data centers.
No, no, all enterprises buy. Every company has got some small portion of their compute sitting on their premise, especially when it comes to control systems. Let us say, if you take a bank, their core banking application usually sits with the bank, very rarely in a cloud. And then because the number of compliances that are there are pretty complex, and then you have ERP systems a lot of times. So the asset could be owned by the customer. They would sit in a data center like ours, or it sits on customer premises, but the asset is owned by the end customer. In case of cloud, the asset is owned by us. I mean, so that's the so no, no. I mean, that's the way people operate.
Okay, okay, okay. Uh, I had that question in between about why Linux dominates. You were selling Microsoft's Windows Server, so it looked like you were not able to make a dent in the market. Why is that?
No, that's primarily because the strategy. Perhaps I mean I wouldn't know the actual strategy behind it, but at that time, software was pirated big time. Like in Microsoft, our office was in a building called Great Eastern Center. I mean, and
And Nehru
we
Place,
were
I
in
think.
narrow place. So you know the place. I mean, so you go one floor down, I mean, to the ground floor, and you walk around. Either you get Chole Bhature or you get SAP, Adobe. I mean, you name it, the software. You get everything
Yeah,
there, the
yeah,
oracles
yeah.
and all that. So the whole challenge was, how do we make people convert from pirated software to that was the common challenge between us, Oracle, everybody who was selling software. But yeah, people just convert because there were no very big legal hurdles in using at that time. Today it is much more firm. I mean, and it's all matured. But when I was there, we couldn't really take people to. I mean, go on a path where we go and do something legal, threaten with legal action and all that. So it was only praying. I mean, so you would go to large customers and then you pray that please convert it. That's how it was.
Uh, my question is this: that for businesses, asking them to pay for software is much easier than asking consumers to pay for software. I would have thought that the server world is pure B2B kind of a world. Businesses are the ones who will buy the software which runs servers. So Microsoft had a fair opportunity to have a significant presence there, but you're saying that 99% of the internet runs on Linux. Why did that happen?
So, but as you said, I mean, I think consumer wouldn't buy. So, what Microsoft did was primarily bundled it When you buy the PC, you get Windows. I mean, so they actually work with the OE. On the server side, till the servers were primarily connected to internet, people were generally fine. I mean, but the moment servers had to connect to internet for security updates or patches or something like that, all the software guys could actually go and verify whether that's a legal version and only update when if it's legal version. Otherwise, you keep giving warnings and stuff like that. So I think the change happened because more applications started connecting to internet, and we could realize what was happening underneath with whether the operating system was legal or not. So if you take the original thought process, see, there were these bigger systems which IBM and all made. They were called the RISC systems. I mean, most of the x86 machines that we work with, which was actually invented by Intel, they are called complex instruction set, and RISC is reduced instruction set. So there was an operating system called Unix running there. So the guy who did Linux was actually brought what Unix offered in larger systems on a x86 platform. So the moment he wrote that, it brought in a lot of those legacy thought processes in terms of making it very robust and transaction performance and stuff like that. That aspects came into the x86. So when that happened, I mean, it was the preferred choice, and Linux was free. You had much more control. It's open source. You have code available if you want to alter it. If you want support, there were people supporting it, like, oh, there is Ubuntu, there's Red Hat, and kind of took off.
Okay, interesting. So the need for more customization, backward compatibility, some of those things were also responsible for Linux dominating. Because
Yeah,
Linux is more.
and and Windows was actually an upgrade from a desktop, whereas Linux was has a lineage to larger machines like mainframes and all that. So traditionally, Linux outperformed Windows.
Okay, and so that early adoption meant more support, more developers building applications on it. What happened with Android, right? Like, because the more apps are built on a platform, the more powerful that platform becomes. So something similar happened here. Okay.
Yeah, it's basically how you process a set of instructions. I mean, if you see the original computers were actually built for mathematical purposes. So the instruction set was not really complex in the sense they just had to understand few characters. It was not really they were not really working on understanding more than the alphabets and the numbers. I mean, so it's 0 to 9, and then you have a set of alphabets, and that's what was required. So it's reduction set. I mean, that's how you can look at it. It's a little bit more depth is required, but that's how it was. But when complex instruction set started, people looked at 256 character base. I mean, so the character base was we had many more symbols that were available. So the machine had to represent and understand more number of characters. I mean, and that's so that it is much more relatable to a end consumer. The Intel is not the original designer. I mean, actually, IBM invented this again on the desktop side also. But at that time, I mean, two processors were competing. One was Intel, other was from Motorola. Those were the choices available, but Intel prevailed, and then Intel took that. When I started working, it was 4-bit process. Now it's
The
64 bit.
Intel processor was the x86.
Yeah. So I started with 8084. I mean, then there is so the first processor which was basically commercial was 8088, and that understood the the full character base that was working on those operating systems. When it was mathematical, it was not very good. So you had an option to buy 8087, which could offload complex mathematical requirements. So the way the current processors work, they can do a lot more things, but they are not good at math. That's why the GPUs came up, right? Which are good at math. So it was, I think, conscious giveaway because we were trying to make PCs more versatile, doing many more tasks like graphics, create documents and stuff like that, not just do mathematical functions. So that's how the x86 architecture evolved.
Yeah, what was the difference between Motorola's option and Intel's option?
No, not. I mean, see, finally you had to find, adhere to this x86 architecture because the chip has to talk to many other outside elements. So the architecture on the outside is the same. It's just that one set was made by Motorola, the other set was made by Intel. But I think Intel took quick steps. From 8086, it made 80286, then 386, then 486. Then there was Pentium, then, like that.
My first computer was a 486. So yeah.
Oh. So till 486, you had an option to add 487 for if you had a lot of mathematical calculations, like you're
Okay.
running Fortran or something.
Okay. And where does this risk and CSC come in this? Like,
So
what's
the
the connection?
so I told you the risk was the original mainframe thought process,
Right. Reduced
and
instructions.
those still are in some form available. So IBM still has a range of machines called power systems, which are the lineage from there. So they still have mainframes which run very large banks, or but you don't need now. I mean, because so in what you can do with one large machine in a mainframe today, you do it with few of these comparatively inexpensive servers that we have.
Okay, so you told me PC and server. What is mainframe so in our analogy, like a PC is a car, a server is a truck. What is a mainframe?
It's like A380. I mean, Airbus A380. Uh,
Okay, Airbus A380. Okay.
yeah,
And so, like, it's a lot bigger, a lot more processors or
yeah,
cores, a lot more memory, a lot more storage. That
and
is a mainframe.
expensive to run, and it is not efficient. I mean, so I
It's
think
not
they are not.
efficient because it uses the RISC architecture.
No, no, not really that. I mean, so basically, you see, the volumes are not so many, and the priority is not about, see, efficiency comes also in the amount, I mean, the talent that you require to run it. It's so you need much more um, closer to machine language kind of experience to actually run these things. So, of course, today you can compile any language on mainframe, but those are very very differently done. Today we use most systems. So how does it happen when we want to run? Let's say we run elections today in India. We put maybe 100 200 servers, and there is something called load balancer in front. I get a request from you, I send it to the first server, the second guy is send it to second. So the load balancer manages the load across hundreds of servers. In a mainframe, it's one guy who's got 30 32 or 64 processors, takes all the loads, it crunches on its own. So very good for a banking application. It could even do UPI very well, but UPI runs on x86 only. But it's meant for a lot of transaction load. But it's a single big machine versus multiple small machines.
Okay. And so it can handle peaks very well, but it is inefficient because when there is no peak situation, then there's a lot of idle capacity. It's not agile. You cannot like redeploy it for something else when you don't have peak capacity. Whereas with servers, there's more agility to handle peaks of different natures from different sources, etc. So you can do that more agility. That is the main difference here.
Yeah, and applications have changed a lot. So if you take elections, during Lok Sabha elections, we need to scale almost 21 times more from every day to that day. So 9 days last year, we worked at between 16 to 21x. But during smaller elections, let's say Maharashtra or something, it'll be 2 3x. I mean, but so this is what this new architecture facilitates. You could expand. So it's called elasticity. So you could expand and contract.
Okay.
You can't do that in mainframes.
So when there is this kind of massive, like 25x additional load needed or additional capacity needed, how is that capacity generated?
So as a cloud provider, you need to have capacity. I mean, so it's just that customer pays you on consumption. So you keep the capacity idle. So the way you manage it is that it's like a bank. I mean, you go to a bank. If all of us withdraw all the money we have, bank won't have the cash. I mean, so it's the same funda here. So we manage it smartly. The anticipation is that when Book My Show has got a big movie launch, I'm not having elections. So, some capacity is available for Book My Show because there is no election. But you have 2, 3 events, then you need to have much more. But that's how you manage it. You manage it. There are quite a lot of good tools available, and it's
Mm.
pretty
Okay.
smartly done.
Okay, understood. Coming back to Intel a little bit more, um, there are uh, even in the processors, there are all these different processor wars happening. In a way, Apple has its own chip series of M1, and they moved out of Intel. And you also have ARM, and ARM is what is the backbone of, say, a Qualcomm Snapdragon. I believe those are on the ARM architecture. What are these things? I mean, I read about these things very superficially. I don't really have a deeper understanding of what all of this means. Can you just help me understand, like, what was the Intel architecture? What is the Apple? What is ARM? Are there other such options also which I should be aware of?
No, only just I think there are two architectures like x86 and there is ARM. When so they've outsourced the because you always create a standard and you leave it outside while you build the chips. I mean, everybody can follow the standard, but you can also take the standard and you can use it. Like AMD has taken x86 architecture and started building similar processors as Intel.
Okay.
And
So
original x86 was actually done by IBM.
okay. So IBM, Intel, AMD are all of the same lineage using the x86 architecture. Of course, they are improving it each year and upgrading it. Got it. So that is one type of architecture. And what is ARM? How is it different from x86?
Uh, it's so everybody has now gone to a stage where the processor is no longer one compute engine. What they've done is everybody has packaged multiple compute engines, and then they've made a small load balancer and a router inside which distributes the load and makes it work. So one of the problems that we have in electronics today is how much can we pack. Because see, as the transistors get closer and closer, they also emit electromagnetic interferences on each other. So what you do, you keep reducing the power that they consume so that the electromagnetic interference also goes down, because it's directly proportional to the power that you give it to that. So processors are becoming more efficient, and it is when you make it more efficient, you can also package them much closer. The current thought process, current manufacturing process, the best is 2 nanometer. That is, there's just 2 nanometer of space between two transistors. So one of the things that happened was Intel couldn't package much more. They got stalled, and their chips started becoming. So, for example, the speed at which they run kind of became 2 gigahertz around that, and they were not really scaling. And also, you couldn't pack too much. And that was because of the die architecture and all which Intel had adopted, and it was not as good as what the Taiwanese were doing, like TSMC and all those guys. So now almost everybody, all the big guys, are producing their own chip because the chip design is possible now. There are very good tools to design and a lot of talent available. So they design the chip, and then you give it to TSMC to produce. Since TSMC has got a better manufacturing process, they produce a much more efficient chip. So you package more because they consume less electricity, and you package it more, and then you also design it to meet your requirements better. So it's always Intel and Microsoft had two big problems to solve. One is the downward compatibility, in the sense that there were so many legacy systems in place that whatever they do, it had to be backward compatible. Um, but whereas if you see Apple and all, you can't run the current Mac OS on a older Mac OS because the silicon is totally different.
Okay, interesting. I'm just going to recap some of what you said. Um, so TSMC is what's known as a foundry. So they manufacture chips based on customer specs. They don't design and they don't have their own brand. You and me cannot go and buy a TSMC chip for our laptop, but an Apple can go and place an order with TSMC for chips, and TSMC will make it. So therefore, for larger companies, uh, today the ecosystem exists for them to have their own chips because you have an efficient foundry in the form of TSMC, and you have the chip design infrastructure, both in terms of enough talent and other enablers, and therefore Apple has its own M series of chips, or like Google has the Tensor,
Yeah.
and so on and so forth. Okay, understood. Where is the role of ARM in this?
So the new people like Apple has taken ARM as the base design. You need to have some foundation design. ARM is the foundation design. They're of course nowhere similar to ARM's own processors, but the outside connectivity, all those other systems are compatible to ARM architecture. So just like x86, it's an outside. It is how you shake hand with other systems.
It's like a protocol. Like one way to understand ARM
Yeah,
is it's a protocol. Okay.
yeah.
So ARM is selling like intellectual property to people who want to make their own chips. So they have like a chip architecture and instructions
I
on
don't
how
think
to.
so. See,
Okay.
you can't win like that. So, see, they had this very formidable x86, which Intel and AMD were leveraging. Now, if ARM had to compete, if they said, okay, you have to give me royalty, nobody would have taken it. So, it's an open source design. So people leverage it, use it however they want.
How does ARM make money then?
ARM makes chips. They also make
Okay.
processors and
They also make
yeah.
processor. What's it? I've never heard of like a laptop or a phone with an ARM processor.
No,
Is
they
it
make
branded as
primarily
ARM?
for servers. Yeah,
Oh,
you
servers.
get them.
Okay.
Yeah, but people mostly use them in servers, but they are very small. They are not like, so their thought process is smaller unit, many of them. Whereas AMD is really putting lots of codes now and making the processor really powerful. That's because of this, 4 nanometer, 2 nanometer. Most server processors are 4 nanometer. Most mobile processors and all are getting to 2 nanometer.
Okay. Okay. Like the Snapdragons, they are like 2 nanometer. Okay.
Yeah,
Okay.
because in mobile you want to consume less power, generate less heat. In
Hmm.
server you are much more liberal. I mean,
Right. And miniaturization matters more for mobile devices. Okay. Okay.
no,
So that
and
was
they
a
need to be pretty robust. So it's not like you have a cooling fan in your phone. So when the processor is running, it needs to cool by dissipating heat within the phone itself. Whereas in a server you have a fan and there's a heat sink. There's a whole lot of stuff that works for heat removal.
okay. Okay, got it. Fascinating. Okay, so we took a long detour. Let's come back to you were at Microsoft, kind of frustrated in your job. You were responsible for Windows servers. So how did that lead to your entrepreneurial journey starting?
Yeah, so no, after Microsoft, I mean, I joined Reliance. I mean, of course, the opportunity was humongous. I mean, in the sense, see, one of the things that I didn't want to do ever was that go to the same customer and sell a competing product. I mean, because you kind of lose credibility. So from Dell, I didn't join Compaq or Digital or somebody or HP, but I joined Microsoft. It was far easier to communicate to the same set of customers. Then I moved to telecom. Again, you learn much more. It's new industry, but the opportunity that Reliance showed was massive. Like, at that time I was paying 16 rupees for a call. I mean, whether I receive it or make it. From there, Reliance had a thought process that we should make it 40 paisa. So you go and hear such audacious, objectives. I mean, you want to be part of it. So maybe I'm the first 50,000 in Reliance who started that company. I actually
This you're
joined in
talking of
Reliance.
the version one telecom, the CDMA. Uh,
Yeah. I was
the
there
okay.
from CDMA to GSM. I mean, but I was related to the enterprise larger networks. I mean, that's what we were doing. But what happened? So whatever financial goals I had, I kind of met them in Reliance. I mean, so Reliance. See, obviously, I mean, Dell paid me very well, and then Microsoft paid me better. Reliance gave me much. So the option that we had at that time was very, very unique. I don't think people go through this kind of jumps these days. But um, our salaries perhaps were looked at in dollar terms, and they were very sympathetic towards us, and they paid us too much. I mean, so
Okay.
yeah, I mean,
Reliance had that strategy that we want best of the breed people, and we
that's
will
true. I mean,
pay whatever is needed to attract
yeah,
them.
so
Otherwise,
they
they
would.
won't have been able to attract someone from Microsoft, right? Like
Yeah,
at that
not only
time,
that.
right?
Yeah, not only that. Actually, I spent 7.5 years in Reliance. They doubled my salary twice for what we
Wow,
did.
wow.
So, it's not just about acquisition. I think I found that at least my bosses, I mean, the people whom I have worked for, they were very generous, and they were always generous in proportion to the contribution you are making. So it was very good. So that became a problem for me because
Just
uh,
one question on this compensation strategy of Reliance. You wouldn't see this strategy even with, like, say, a Google or a Microsoft, right? Like for them to double salary of people who perform well. Like,
no, they
what's
don't
your
need.
take on?
Oh, they don't need to, because all these big brands. So that's our biggest problem, right? The talent goes to them first. It's like, you pass out of IIT, you want to go and work with Microsoft, Google, or Nvidia now, and those kind of. I mean, so they don't pay more. So if you see today in software industry, TCS pays the least, but I have to pay almost two times more than what TCS pays to a developer. I mean, that's how. So big company doesn't mean big bucks. That was only during my time.
Okay, got it. Reliance was still not as known and respected a brand as it is today with Geo. So therefore, they had that kind of compensation strategy. Okay, understood. Right.
No, and there was this incoming salary which was a benchmark. I mean, so you had to, I mean, they had to match it. And so what happened is that, when I was in college, I thought I learned 20 lakh rupees. Okay. Then when I got married, I increased it to 32 lakhs. That was my lifetime goal. But I kept on increasing my goals as, my compensation improved. But in Reliance, one of the things that happened is that, I had secured my kids' education. That is, they go abroad and study. I've secured that. I had a house. I had two cars. I was debt free, and I was 38. I didn't know what to do. I mean, so one of the things that I had to do was actually set some goal. And around 40, I thought I'll get out and start something because there was too much of comfort in my career. Um, I spent 7 years there. They won't sack me so easily unless I blatantly make some mistake. But um, so I had to just reinvent because otherwise, there was my life was going nowhere. I mean, that's how
So
we
you
started.
in Reliance, you were doing enterprise sales of connectivity
I was
solutions.
in
Like,
Western region. I was head of Western region. I was in
okay,
Mumbai,
you were
and
selling them internet connectivity, like enterprise
yeah,
grade internet
yeah.
connectivity.
No, so there at that time we used to do enterprise mobile. A lot of we had few data center was one of the offering. Um,
Okay, okay,
yeah, so
okay,
I
got it.
had so there was a element of compute in that. But
So
my
why did
my
you? Yeah.
customers were like SBI, ICSI. These are like for SBI we did maybe 10,000 ATM connectivity. So it's like 10,000 connections. Both HDFC and ICICI Bank, thousands of branches, and they have branches going up. So it was pretty transaction oriented, and yeah. At that time, telecom was not as reliable as well. People would see earlier people would steal telecom cables because they had copper in it. Um, I don't know why they were stealing fiber because it's plastic. I mean, and but they would still steal it. I mean,
Okay,
so a lot of things go down, and it was a lot of firefighting. Uh, yeah, but it was like routine. I mean, you do it for 7.5 years, it's the same thing. There was nothing
right.
new coming. Yeah.
Okay, okay. So why did you choose to become a data center operator? Like when you decided you want to move on and become an entrepreneur?
Yeah, because we saw that opportunity. So at that time, it was telecom guys who were doing it. But for telecom, see, this business was so small that they really didn't invest in it because their priority. Unfortunately, what happened when Reliance was born, the way equipment was amortized was a 7-year plan. I mean, because this telecom equipment lasts longer, so you always thought that you had 7 years to recover your capex. But we launched CDMA, then GSM took over. They got 3G. So you had 3G license to be paid for, and then you had to adopt 3G. Then 4G happened, then 5G happened. So the suddenly in telecom, the whole thought process changed that instead of 7-year cycle, you had to plan for 3-year cycle, and the costs were going down dramatically. So the challenges were um, pretty different in the mobile space, and it was becoming very very competitive. Tata Docomo did this 1 second 1 paisa, and that was the end of making money in telecom. I mean, everybody followed that path. It's a downward spiral, and they couldn't get it back. That's why so many companies died, right? I mean, so in this whole battle, data center, while it was lucrative, my customers were demanding more space, but I never could. Like I go and talk to Anil Ambani and I'll say that look, we want to do this thing. Anil would tell a person called Satish Seth, and that man says, "Okay, I have a building here. You want to take it?" But it's not like we are making a strategy for a business, and so we thought there was an opportunity there. As companies, there were other companies like NetMagic trying to do the same thing. So we thought we should build a data center business. But I chose to do it in Bangalore because doing real estate in Mumbai is very very expensive because data center you need a building and stuff like that. So we thought we'll do it in Bangalore. Even though even from that time Mumbai was the primary market, we started in Bangalore. Yeah, that's how we started.
Okay, okay. Uh, you started alone or you had co-founders?
Yeah, I had at least 6 people who worked with me, friends. So a couple of friends who were chartered accountants because I was, even though I had very good idea of finance, but I couldn't run finance. I mean, so it was like business orientation. I did prepare myself, so I went to Yale for a CEO course. Prior to that I went to Kellogg, that is University of Chicago. So we, even though I prepared, I thought it'll good to have. There are a couple of another friend Bhaskar who joined us, who is in Dell, who joined with me is, and there is Viral who joined
So
from
these are
Reliance
like
only.
founding team members or co-founders?
Founding team members, and a few
Got it.
of us we've got shares and all that. It's nice before you start, but when you start, it's a massive problem because you have to pay 80 people.
Right.
So
Why did you need 80 people on day one?
because it was data center, we need one guy to design, one guy project managing. So we were designing everything in house, and it's a big project. I mean, it was.
Was
Of
this
course, we didn't have.
you know, founders who start young don't come with that corporate baggage. Was this corporate baggage? It sounds like corporate baggage. Like you worked in large companies, seen large teams, etc. Was it that corporate baggage because of which you started with 80 people?
There is. I mean, so I'll tell you, there's one guy who resigned in Reliance, just landed up in Bangalore and told me, "Boss, I've come. Bolo kya karna hai?" Like, so it's not that all these guys pressurize me for salary and all. They worked with me for many years. So there are maybe 10, 12 guys who didn't take salary for 2 years. Right? So it's like,
Wow.
yeah. So so they are the founding team at NxtGen. There are quite a few who couldn't, though their intent was not to take money, but they couldn't manage it because they had personal obligations to do. I mean, you have a home loan and stuff like that. So the 80 is because, I mean, Akshay, it's a larger project. So the first dream was to build a 350 crore data center. So it's not that you must understand where I'm coming from. When you have certain amount of salary and you want to come out and take a risk with everything that you have, the return should be much more than that. Otherwise I was very, very comfortable in the corporate piece and the salaries were very good. Real estate was not so expensive. So it was, things were, we were ahead of the curve. Today, salary catches up with inflation. But, we were way ahead actually. And So when you go through that, I mean, you need to see what is your benchmark. So we were not building a startup which will generate 5 crores turnover because you would take that as one person's salary. I mean, it's not going to work. So if we were all there and we were getting salaries of Reliance, you kind of figure out, okay, this is, let's say it's all amounts to 100 rupees. You needed to do a business which was like 1,000 rupees so that you could take 100 rupees back home. So you have to look at it, and you want to build a larger business, you need so many people to operate. I mean, otherwise you won't get there. So uh, so it's about what you want to get out of it. So I had to get something better than what corporate life paid me. I mean, that was one benchmark. Of course, you had a lot more control and all that, but genuinely in Reliance and Dell, I had an absolute free hand, and my bosses were like angels. I mean, they were too good. So I was like Prince in Reliance. I mean, so I had so it was like you had to have some goal, some benchmark to
Hmm.
set yourself up.
Right. No,
Uh,
no
and
point putting Reliance if you're not going to take a big swing.
yeah, so it was intended to be a bigger swing. Yeah.
Okay, understood. Uh, so how did you go about it? So did you raise funds? How did you actually have your first data center launching? Because it sounds
So
like capital intensive project.
yeah, so I mean, obviously, I had some thoughts in terms of how we would make it different from what was there. So we were putting that design together, and then of course I had option. I mean, so I was from the industry, so I had a friend in Intel who referred to somebody from Intel Capital. I went to meet them just after lunch on one day at about 2 o'clock. 7:30 we agreed to, and we got blessed. So Intel agreed to invest about $9 million. 8.8 was the number, and that was the start. You don't get the money immediately. I mean, then there is a whole lot of stuff that happens after that. So,
There's due
um,
diligence
so
and all of that.
there was nothing to diligence. It's like
Okay, there's
brand
a
new.
paper idea.
Everything is paper. I mean,
Uh,
so we raised 8.8 the first round, and then we thought the rest of it we will get debt. But actually, what happened was that once we had this money, we got 10-acre land because we got land outside. We never wanted to build the data center in an urban area. Nowhere in the world except in India you find data centers in the midst of business districts. So we realized that okay, I mean the rest of it will come as debt. And I started going to banks. I mean, the first thing that I realized is most banks wanted 3 years of balance sheet. So in India, you can't. A bank wouldn't fund you, irrespective of your collateral, if you're less than 3 years. I mean, that's it. You could be loss making. You could be what? I mean, it didn't work. So
and there
luckily,
was
what
no
happened?
like venture debt at that time, like the
No,
private
no, that
credit market.
concept wasn't there. I mean, there
Okay.
was. So we had, but we had started the project. I mean, we got land, we started, I mean, and
You
I was
purchased the
thinking,
land outright instead of leasing it, or like.
no, I got it outright. I mean,
Okay.
at that time, so Karnataka government had a single window scheme. I mean, so you go and apply saying that I want to build a data center. These are the specs. You have there was industries minister called Nirani. I mean, he had a meeting and he approved it. It's a single window, but you go through window, you will find 30 doors. But
Okay.
yeah, I mean, but all said and done, we got land at a very low cost. We got 10 acres of land. So idea was you offer the land as collateral, and then you build the building, and then you get the equipment. And so it didn't work in terms of bank funding, but we got some temporary funding from a cooperative bank. There were a set of old people who came, looked at me, and said that I'll bless you, no problem. And then we got some 30-40 crores and started. Subsequently, I had to raise one more round before we completed the project with IFC, which is World Bank, and Intel participated again, and there was a Spanish company called Axon Partners. They funded us again, and then we completed the project. But what happened with us was that we had to feed ourselves. I mean, even I was not prepared. I mean, by that time, your kids' schooling became the biggest expense that you spend, and and so I had to. I also was looking for some salary. So after the first year, we thought we should start earning some money. It's not just that we build this project and you don't have debt and complications. So we started doing cloud. So I went to Reliance Entertainment. I mean, it's like friends. There are a lot of customers who are my friends. So I went to the CIO. I told him, "Look, this is what I'm doing. I mean, what can I do for you?" He said, "Why don't you build a cloud for me?" So we built a cloud, and that's how we started our cloud journey.
Okay. At this stage, I want to take a detour. What is the, can you define what is the data center? What is cloud? When you say that you originally were building a data center business, but then you also built a cloud business. What are the differences between these things?
So we were discussing about data center versus cloud. The most important thing in electronics is you manage heat, and then you provide stable power. If you can do these, the electronics last for a long time. So what happens in a data center is you give precision cooling and precision power to the servers. So what you build is basically a building which is at least 5 times stronger than a commercial building because you are hosting a lot of steel and aluminum in terms of equipment. And then the second thing that you do is you put certain layers of security. I mean, you put a minimum of three, but normally people put 5 layers of
You're talking of
security.
physical
Physical
security,
security.
or
Yeah,
okay.
yeah. Physical security. Then you have electrical system. If you take our data center, we get power at 11,000 volts. We step it down to 415 volts, which is our three-phase power. So there's a transformer and there is redundancy there. If one fails, what happens, etc. and then you step down. You distribute the power, so there is a lot of paneling, big panels. You will see large cables moving. One system goes to the cooling, the other system goes to the compute, where you go through a UPS systems. Again, UPS, you have one plus one fails, the other takes over, and you have multiple of them. And then there is precision cooling. It's like a very good air conditioner, but very high capacity, and it ensures temperature is maintained. We maintain 22 degrees plus or minus 1 degree. That's what we do, and a lot of other design aspects. So a data center is about a good environment to host compute. So the basic expectation there is that customer buys the compute, which is the server, brings it to data center, and he hosts it there. I would provide a good environment, and I will also provide some connectivity to reach the server, because you can't have free flow of people. You people actually operate it from outside. And that's the data center business. So it's a very real estate kind of business, but it's got certain precision characteristics to that. In a cloud, what happens is you're not only hosting a server, so you own the server asset as well, but you also split that server into, because the server is much larger than what a normal enterprise would need. You split it into multiple pieces and offer it to multiple different use cases. That's so this is cloud business, which is one layer above. Data center is the foundation of this whole thing. It's the environment, and in the environment you put compute, and it becomes cloud.
Okay. So in cloud, uh, you are creating virtual machines in that server, and each virtual machine has a customer mapped to it, basically. And
Yeah,
you are
many customers, like larger ones, I mean, have got 3,000, 4,000 virtual machines. It's not just, no customer has one. So the
got it.
lowest would be maybe three, and the largest would be few thousands.
How do you define a virtual machine?
So it's the same specification as a typical server. So you have certain cores, certain amount of memory, and certain amount of storage. But it is all virtual, in the sense you are not physically allocating to that person. Um, Storage is more or less done physically, but everything else is virtually allocated to you. It's your right to use. If you're not using, I have the right to give it to somebody else.
Okay. Okay. Got it. Okay. Understood. Difference between cloud and data center. So when Reliance Entertainment asked you to set up their cloud, where did you host the servers then?
So in my office, we created a small data center. This was a kind of first prototype. So in our design, we had one thought process of actually designing differently for two aspects. Most data centers are designed for peak heat outside. Um, that is, what is the maximum temperature that that city and humidity that that city has, and then it's designed to handle peak. Our approach was to not design for peak, but between 40 to 80% of usage. In the sense, when is the so if you take Bangalore, it is hot for actually 4 hours in a year. So you don't design it for 4 hours. You actually design it for 80% of the time. What is the temperature? I mean, and that's so our design thought process was different, and we had something called cold aisle containment, that we built a prototype in our office. So we hosted the first cloud in the prototype.
What is this cold oil containment?
So the way air conditioning works is, when you have more heat, you can take out more heat. So um, uh, you the servers typically take cold air from front and leave hot air at the back end. So it's fans which are sucking and pushing out. So if hot air and cold air mix, you don't get so much of difference in the temperature. So the extraction is that much more difficult. So what you do is, you contain the cold air, just cold air in front of the server, and take out the hot air and not let it mix with the cold air. So the temperature is maintained at higher, so the air conditioning systems work much more efficiently. So that's why your ACs don't work well during winter.
Okay. 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 Got it. Okay. Understood. Uh, you're saying AC don't work well during winter in household or in a data center? Like,
Any AC, yeah, household also.
okay.
The more the difference, the faster they will cool. And
Ah, okay. Got it.
yeah,
Okay. Okay. Understood. Uh, so you built this prototype for a cloud. Now, for a data center, you told me the inputs like you need electricity and you need power backup and you need real estate. What are the inputs you need for cloud? Just servers?
no, it's much more complex. So you need first a virtualization layer, which is what happens is you have certain resources. That resources, how do we split it? I mean, that's what is virtualization layer. It is typically an operating system plus certain functionality in that. And then you have large networks.
And this is off the shelf. You can buy from a software company. This
Yeah.
virtualization layer.
So commercial versions, there are companies like VMware, Nutanix, all these guys who do it. We use a lot of open source. We do OpenStack, OpenShift. So because we have that much more capability, we don't depend on a commercial version. So typically, if an enterprise wants to build a private cloud, they will take a commercial one. We're a service provider, so we would prefer to work with open source where you have more control. You can also differentiate, right? You can create certain things which are different, so that your product sells.
Okay. So you were saying things needed as inputs. You need a virtualization layer. What else?
Yeah, and you need networks. I mean, that is how so you can't confine this application to be sitting within the data center. It needs to communicate to the world. So networks, whether it's internet or private networks, and all that is critical. But these days, I think biggest thing is to having a great deal of security capability, because in very simple terms, if it is unsecured, less than a week, any website will be hacked. It's like, there are systems which are probing all the time, looking for insecure items, and then they just hack it. So security layering and the talent around it and the technology around it is a critical element to it. It's and then you work on aspects like reducing latency, improving performance, and stuff like that. So it's a much more challenging job than data centers. Data centers, it's a globally prescribed design. You don't play too much with it in terms of. Um, so the design fundamental is concurrent maintainability. That is, even for maintenance, if you want to take out an element, you can't bring down the production. A data center, once it's switched on, it's never switched off.
Okay. Hmm. Okay. 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 Uh, okay. I understood the virtualization layer, like a VMware kind of a solution or a custom built on open source. Uh, what is the security tool that you use? I believe there's something like Cloudflare, which is uh, used. So is that what you're talking about, or what are you talking about?
Oh no, there are many more layers. I mean, so Cloudflare is typically when you want to secure your internet. But the way they came up as a company is they are a caching company. For example, especially let's take case of Netflix. I mean, Netflix doesn't serve every user from Netflix data center. The movies and the series are actually closer to you. There are cached somewhere. When you pause you can pause it and then you can play from there, but it's not being served from Netflix itself. That's what Cloudflare does. They also offer now internet protection, but that's not what is actually robust. So number one, we have to secure the perimeter. That is, you have people guarding the entry points like internet, private networks, and all that. Typically, these are network firewalls that you deploy. These earlier they were all rule based, but nowadays you can't just manage with rules. So you have advanced threat protection, whereas you are constantly seeing what's happening globally. So everybody shares that input, and then you kind of know that, okay, this is one way people are exploiting, and then you quickly deploy that here. So this is the first layer. The second layer is at the application layer. They are called web application firewalls. Then you have another layer called XDR. Then you have antivirus doesn't work any longer. I mean, because signature based is nobody does it now. I mean, you don't get virus infection nowadays. You actually get hacked. Then there are denial of service. A lot of things that we face today is denial of service. So basically, what people do is they flood you with a lot of requests. I mean, it could be bandwidth or it could be just sheer sessions, and then they won't let you work. I mean, um, yeah, these are the things that we have to handle now.
Yeah. How do you fight a denial of service attack?
So typically, you come to know when somebody is. So these are no longer denial of attack; they are distributed denials of attack. What they do is there are a lot of PCs which are sitting. There, a lot of people don't switch it off. Actually, we should switch off every PC. They are all sitting idle, and each PC could act as a legitimate user coming to our websites. I mean, so what you do is you keep looking at those patterns. If it's the same guy doing multiple and doesn't look normal, you start ignoring him. That's how you and you do it at scale. It's not like you get attacked from one IP. I mean, you get attacked from thousands of IP. These are all um, there'll be
Commandeered
from our
PCs.
office. Yeah.
Okay, okay. Like someone has hacked a lot of PCs and commandeered them.
Yeah. So earlier we used to think, China is attempting to hack. I mean, it doesn't happen like that. You will have a global attack which can come from Ukraine or Brazil or someplace. But today you will see that 60-70% of the attacks come from internal. But that doesn't mean that Indians are attacking Indian websites. I mean, it's basically somebody who's hacked them and then they do this.
Okay, 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 okay. Understood. Okay, okay. So understood. Now let's go back to your journey. You started with the cloud. That probably got some revenue going in before your data center went live. This was which year when the cloud order came in from Reliance?
So cloud was 2014. 2012 we started, but 12 is like setting up of company, going through that. I think the scheme was called Udan or
Fundraise.
something. No,
Okay.
the getting the land and all that. I mean, and then we went through the fundraise. So 13 is when kind of things started taking shape. To 2013, we started building the data center. We got the land and all that. 14 we had to do because 2012 to 14 we were exhausting our savings and all that. You can't build data center business with your savings. I mean, not from salary. I mean, unless your dad has made a lot of money, I mean, you can attempt it. But I didn't have that comfort. So we were making money. Then my second customer. Then since we were building a data center and our thought process was new, we Prime Focus was building a small facility for themselves. So we presented our thought process in terms of how we were doing it differently. They liked it. Also in Mumbai, I mean, they were in a building which had only 9 feet, and you had to design it totally differently. So Prime Focus was one time when we had to. I mean, our design was actually deployed, and like that. So we acquired some known customers. We knew a lot of enterprises. Um,
What is Prime Focus line of business? What do they do?
oh, they do all the VFX post production for movies.
Okay, got it. So they need a data center. Okay. So you kind
Yeah,
of
and it's ridiculously secure. See, because movies are the most because everybody wants pirated content.
right.
So post production is the best place to get it.
Hmm. So this was like a build, operate, transfer thing that you did for Prime Focus. Okay.
So yeah, these were the first two customers, and then now we have 1,000 plus.
So when did your own data center go live?
2015.
Hmm.
Uh,
Okay.
it took us a couple of years to build it. We had so actually what happened was we looked for land where Bangalore receives power. We didn't want to get into the urban infrastructure. So they were Bangalore receives power from 5 locations from the national grid. But only 2 locations there was spare capacity available. One was in Kolar, the other was in Bidadi. So we went and asked the government to give us industrial land at around this place. In Bidadi, that was a very mature industrial area. There was Toyota, which was operating for 20 years. And Toyota, typically, these automotives come with a lot of ancillary units. So it was a very mature place. So there was a small hill available. They said, you can take this hill. And they gave that dirt cheap to us. So that was 42-meter hill. We chopped it off at 21 meters and built a facility on top.
Okay. 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 So what did your revenue trajectory look like once the data center went live? What kind of annual revenues were you doing? How did the business evolve further in cloud versus data center? Which side was growing faster?
So data center never caught up. Because cloud was what all the enterprises were asking, because people didn't want to do capex, except in banking where cost of capital is very low. They would prefer to do their capex. Every other industry cost of capital was 16-18%. They were always preferred to leverage it from as a service. I mean, so cloud took off big time. I also had another opportunity. There was a company called Dimension Data. The Dimension Data was actually built some a DC business for BSNL. I acquired that business instead of building. So I acquired 6 more data centers across the country from because Dimension Data.
Wow.
So
Okay. Okay. Uh, did you raise more funds to fund the acquisition or like?
it's middle class mentality. We want to spend the money we earn. Now I'm raising, but I'm raising a very large amount of money. But see, we generate 100, 150 crores. We spend that on capex or on people. So my investors are happy. I mean, we are growing. It's a growing market, and every year we can put back 100 crores plus. I mean, so it's quite good. See, unless we were looking for a quantum jump, there was no point raising money. Like what? So we cleaned up the whole thing. We are debt free. That original debt I took, I paid off. So it's kind of I'm in a position where I was in Reliance now. Kind of.
Okay.
That's why I'm doing
Time,
AI.
a time for the next big swing.
Yeah.
So,
Yeah, it was just trying to consolidate. You should always have your foundation rock solid. I mean, that gives you maybe it'll take away some little bit of time, but it gives you much better platform to take off.
okay. Just to help me understand the revenues, like by 2018, 2019, what kind of annual revenues were you doing?
We're privately held. Normally, we don't say revenues, but but you must understand. See the maybe initially. So I think the first year itself we did more than 10 million.
Okay.
But the key is that we were EBITDA positive.
First year after data center go live, like 2015, you're calling as first year.
No, 2014. Um,
Okay. The
yeah,
cloud
2014.
business.
Yeah,
Okay.
yeah. So we were EBITDA positive, and from then onwards we were EBITDA positive. We always never took out capital for paying salaries. We always paid it from the earnings from the business, and that helped me quite a lot because I didn't have to keep on looking back and see whether everything is normal. I mean, so we had a good opportunity. It is true. It question there are during the same time I've seen likes of Flipkarts and all that happening, and even now a lot of companies lose money. But I keep telling myself the purpose of doing business is making money, and so we want to make money and deliver value to our customers and not really go in that trajectory of losing money and then gaining market share.
By when did you cross 100 million revenue? By which year?
About 3 years. So COVID was actually pretty unique for us. So the key part of that was on the private sector. We had tremendous stress. My biggest customer was Book My Show, and it shut down. There were no movies, no events, nothing. I mean, so private customers, everybody, including Mahindra's, Toyota Kirloskar is another big customer, Godrej. I mean, they were shut down. Factories, everything was. But at the same time, I had a great opportunity to serve Ministry of Health. government took off. And I don't know whether it was by design or what. Even our income tax refunds came, and COVID time, our business grew. We actually gave increments to our teams, and we also housed most of the team in a five-star hotel
Wow.
for five
Okay.
months. Because of
Amazing.
course,
Amazing.
I mean, because it was far easier if I was going to allow them to go home or go to their PG and come back, they would bring back COVID. So we hired Marriott in Whitefield. For 5 months, we all, I mean, most of the team stayed there. So it was like contained piece, because we had to work 24/7. um, we did quite a lot of good things during COVID. So COVID was a time of growth. I mean, so to answer your question, that is like kind of pivoting point, because that shows that you are a resilient business. I was very surprised. Very large companies started deferring payments to us in like second month, third month onwards. Whereas we paid all the salaries, and so I think the character stood out during COVID, and from COVID, of course, when the growth trajectory has been different.
What are you today now? Like 300 million plus or like 200 or like what?
No, I can't tell you the number. I mean, but basically, I don't have 300 million revenue now. I mean, but we have. I mean, but our EBITDA now works around 44%, which is a very
Wow.
healthy EBITDA to do. But we also have a lot of depreciation. So last year our profit was small, but this year, I mean, we could pay a lot more tax than what paid last year, because more or less, actually, this business has got a lot of fixed cost. It's not people dependent. It is a lot of automation and technology dependent. So you get to certain scale, you're not really dependent on people to scale this business. So you actually need to um, just leverage technology.
Amazing. Amazing. Uh, okay. I want to understand. You said that the data center business did not take off as much as the cloud business did. So essentially, the data center business is like your internal vendor, and the cloud business is the primary customer for that data center.
Yeah. So we operate five data centers now. We actually shut down Jaipur and Ludhiana. So it's the foundation of our cloud. But the first failure level. I mean, so if DC fails, the whole cloud goes, and 1,000 customers go down. So we can't afford that. So it's a critical component of the business, but it's part of the offering, not the offering.
But I mean, the data center is like the base layer for your internal supply chain. That's the way to look at it. It's not necessarily something you monetize by directly selling to end customers. What is being monetized more is the cloud business.
So I'll tell you, when I do data center business, I will get on a per rack basis. I mean, I may get about 6 lakh rupees revenue per annum, and you need to invest maybe 18, 19 lakh rupees to build that racks, infrastructure behind. So you will take 3, 4 years to recover, including interest. You need 4 years to recover, but that infrastructure can last for quite a long time. But whereas if you go to cloud, each rack can deliver 2 crores of revenue.
Wow. Okay.
Of course, the related investment is higher, but the margins are also higher. So it's a better business to do. It doesn't demand so much of capital, um, and we make money so we can put back the same money.
Amazing. Uh, is this generally the model for other cloud providers also, like say Azure or AWS? Do they own their own data centers as well? Is this generally how the industry works? Like,
They do, but in countries like India, they don't. But they started, like Microsoft started owning pieces. I mean, but they will structure it differently. But I will give you the same perspective. So if you take AWS for Amazon, I think it is 17% of their revenue, but 69% of their profit.
yes, yes, yes. AWS is their profit-making machine. Yeah.
It's everywhere. So it's a very good business to do.
I'm assuming this is very low churn business. Like once you acquire a customer, they stay with you.
Yeah, very, very, very rarely. In fact, last year it was 100% voluntary from our side because somebody wouldn't pay, or they've gone down as a business. I mean, and stuff like that. But people don't move out. In fact, the beauty about this business is existing customers give you 24% growth.
Because their need for data is only going to
Yeah, it
increase.
increases. So
Right.
last 5 years, it's been CAGR of 24% on my existing customer base. So it's a
Wow.
so if you serve them well, you actually don't need to acquire new customers. I mean, so if we grow maybe 35, sometimes 40, 35%, 24% comes from existing customer base. So new acquisition only is smaller because it's always difficult to acquire new customer.
Okay. Okay. So, like, you're planning a big fundraise. Is that for more new customer acquisition? What is that for? And how much is the quantum you're planning to raise?
We are raising about 400 million now, primarily for
Wow.
AI.
Okay.
Uh, the reason being that this cloud is not a stationary business. That business is growing. I can't take out and then start AI from that. Then this business becomes weak. This is in a nice trajectory, and I don't want to stress that business. So we were raising a new set of money on for AI. Uh,
So,
it's
AI is an
basically
op.
very, very different thought process from the way people are building businesses now. Perhaps it's my age or upbringing or whatever. I mean, but this is our approach.
AI is essentially like the industry is going through a change, and AI is an opportunity to acquire customers from like an AWS, because cloud customers don't churn easily. So either you go after startups and be with them as they grow, or you look for these industry changing moments when the industry is changing, and therefore you have an opportunity to acquire customers. So that is the plan here. Like you want to acquire the next set of customers through the AI opportunity which is coming in.
Yeah, so AI is also changing the dynamics. So the three guys who dominate cloud, right, globally, AWS, Azure, which is Microsoft, and Google. AWS has lost the race. I mean, they're not there. Um, it's
Really,
Microsoft.
how
I mean,
did
they're
that?
not there.
AWS
No,
was the pioneer, right? It was the company
no,
that
no, in
everyone.
cloud, but not in AI. It's Google
Not in
who's the
AI. Okay,
yeah.
okay,
So I mean, they're under severe stress. I mean, they're missing out this entire bus. Google is doing very well. I mean, because they have the tools. They started this tensor and that thought process. So, but Google always struggles to succeed in a consumer business. So Google won't ever. I mean, they've never showed that their Pixel phone or nobody buys. I mean, right? I mean, they don't get to. The only business they succeeded was search. I mean, beyond that, they never succeeded in any ventures. So Google is ahead of AWS, but Microsoft is in a rock solid place um, because of MS Office. Because MS Office is front end to most businesses. I mean, Excel today is as good as a BI tool. And you add AI to Microsoft Office, they are at a significantly so. And consumer play is gone because Meta will take lead. We use a lot of Meta's open source pieces. Uh, OpenAI, everybody knows. I mean, ChatGPT. So we are not going to compete in the Meta AI space, but we build enterprise use cases for our customers, and we run it for the long term. So, like we can do a bot for your customers. We can analyze your corporate, I mean, your videos or things like that. So we do various use cases. Why we are doing use cases? That once you build a use case and then you put it, it runs for a long time and it consumes my infrastructure, which is my core business.
okay. So the data center business is like selling real estate in a way. It is a very infrastructure play. Cloud business is one level above that, where you abstracted the real estate and the upfront capital investment, and made it available on tap through subscription. Uh, but it is still somewhat of an infrastructure, but more of a compute infrastructure. Now, in the AI business, you are going more towards applications. It is no longer infrastructure which you are selling.
Yeah, because if I wait for somebody to create these applications, I will lose the opportunity to host them as well. Because the beauty about AI is AI creates AI. So I'll give you an example. There is a popular credit card aggregator, payments aggregator. Um, they wanted us to do a chatbot for their customers, but they didn't want to give us credit card bills of their customers because they can't. I mean, they are legally bound and they've committed to the end customers. They won't do. So what did we do? We asked AI to create credit card bills. So I created 2000 bills. AI created it with all the format, transactions, everything. Gave that to the model, which is the chatbot, and said, these are the credit card bills. Understand the queries that customers will ask and then respond. So in a week, without data, we were able to create a use case. That's the beauty about AI. So there is something called SDG, which is synthetic data generation. That's what is catching up. The really you don't need a lot of data to create. You need a little bit of data so that it understands what is it that you want to create. So, for example, I gave my credit card bill to the this thing saying that I want you to create a 2000 of this with different names and different transactions. So that's the beauty about AI. So the AI is accelerating so many use cases, and it's far easier to build applications these days. You don't need to code. I have a BBA graduate who knows nothing about Python but delivers Python code. And this is all young generation. These guys work really hard, and they are excited. So it's very easy to build these things. So we've already built 38 use cases for enterprises. So you build it and you host it and you run it for the long term. That's how we want to go about it.
Amazing, amazing. Okay, let's take another detour. I want to understand the AI opportunity from a zoomed out perspective. Like one part of the AI opportunity is what we're seeing with Nvidia, like becoming $1 trillion market capitalization and so on. And then the on the other extreme, you have like AI wrapper SaaS products, like SaaS products which have an AI behind it. They put a wrapper on it, and in between there would be other layers also. Could you take me through? Maybe let's start from the GPU opportunity here. What is a GPU? How is it different from a CPU? Why is Nvidia $1 trillion company?
So if you see what was game, a game is typically mathematical calculations at the behind. While you see the graphics, everything is mathematics at the back end. So I told you about processors not being able to do mathematics very well. So they took the older generation and created a mathematical processor. That is what is GPU. I mean, though it's graphical, but actually it is doing mathematics because of placing a pixel or everything is mathematically calculated. So Nvidia was doing a lot of these gaming cards where you put those cards, and then so it was a very small company. Uh, AI is there since a long time, but people were doing something like deep learning, machine learning. Machine learning is you learn patterns and then you repeat the patterns. Deep learning is you really go deeper and understand what really happened and create patterns. So AI was thought process was happening. One of the beautiful things that they happened is they used GPUs to actually create what they call generational AI now, which is it is generating content. So far, it was not generating content; it was computing. It was just answering a formula. But the Gen AI is where people started generating something with it, like a text or image or something like that. When that happened, and it happened on NVIDIA saw the opportunity and started building better and better and better. So I think they were at right time at right place, and then they took off. There are other guys who are doing graphics cards like AMD. They've got a range called Radeon, and they are also doing this. They are second in line today. Intel lost the race. I mean, on both CPU and GPU. But what is happening on the GPU front? You will have there is this training workloads today where everybody is looking at building models. There you need these big GPUs and then your large set of data, and then you process it and then you make it learn. And so there are people who are buying these large GPUs today. 80% of these large GPUs which are made are consumed by the top 5 6 guys, right? OpenAI, Meta, and all these guys, Twitter, all these guys are buying off most of the capacity. Then the rest of it comes to people like us. And but what is happening is once these models are done, you don't need so much compute capacity. So there are a lot of new guys coming up who are building different ways of actually querying these models. So that's they call it inference. So the first set is training. The second thing is you infer the knowledge that the training it has from the training it has acquired. So you're inferring, and inferring doesn't require so much of compute. So there could be other people who will come in. So I think for the next 3 years there is no question of Nvidia losing ground, and they also realize that, and they're doing a whole lot of work on the inferencing front. They have something called Dynamo. They also help people build use cases. There are tools which are building. Nvidia is way ahead, and they have at least 3 years of ramp up. But 4 5 years hence, we will have multiple ways of doing things, but not next 3 years. On the software side, there are these models. I mean, so there are closed models, which is ChatGPT. We don't know what the hell happens behind it, but ChatGPT learns from the user as well. It is closed, but whatever you are asking, whatever you're getting, whatever you're giving, it's learning from that so that it improves itself. Then there is likes of Meta. Meta processes the data that it has, which you have consented. That's what they say, and they build that model. But they are also giving away that technology, open source it. They call it that models are called Llama 3, 4. Now we have 4 version and all, which we all could use. So they are actually giving back something to the society at large with open source. There are other companies like Mistral who are building open source. That is the second set of people. Um, and so there are third set of people who are actually leveraging these models and building use cases by fine tuning them, altering them because you have access to the source code. That's people like us. That's the software side of things.
Okay, understood. Does open source mean free? When you're saying Llama is an open source model, it means that it's free. You can just download it on a server and have your own chat bot.
Yeah, you can do that. That's what it is. I mean, so there is a globally accepted license called Apache. I mean, there are 2 or 3 versions of it. Primarily, they say that in case you alter it and you do something better, please give it back to the community. This is what they request. It's not mandated, but you have full access to the code.
So why is Meta doing this? How are they going to monetize all this effort of?
Oh, they are monetizing, right? I mean, so in your WhatsApp, there is. So today, I don't think these big companies are really worried about monetizing. They are worried about the knowledge that they are getting in terms of what their models can do. But you just imagine what they've been able to do. You can ask a medical question, you can ask a physics question, they would still answer. So the amount of data they got trained, it is not related to what we are posting in Facebook and all. They've gone way ahead. And all the models are better lawyers, better doctors, better physicists than like 95% of the people, and all combined into one. So that's the lethal combination that they are generating. I don't know what is the long term thought process, but none of us can create anything close to that because we don't have access to that data, nor have the resources to process that.
No, but Okay, maybe Meta has multiple sources of revenue, but say you said Mistral is also doing open source LLM. Why do an open source LLM if it's going away for free? What's the business model?
So for any open source, it's basically there are smart people who want to showcase their alternative approach to things. I mean, Linux was the greatest example, right? I mean, it's one guy who built it, and it powers most of the internet. I mean, that's it. So that's the beauty of it. So it's a thriving community. There's nothing that's not available on open source. So if you want to build a drug, there are models available on open source to work with. Today, people are also putting voluntary data sets for building models on open source. I mean, even our Indian government has got AI course, I mean, which is a voluntary, whatever data that can be shared, they're putting it there so that you can take it, leverage it, and build models.
Okay, okay. But I mean, someone like a Mistral would have raised funds from investors, from VCs to build an open source model. The
No,
VCs,
it doesn't work like that. So, in an organization, what happens is there are 20 people. It's not very large teams which build it. Actually, it's like 20, 30 people because large teams, they are very difficult to manage. You won't get. Whereas when it comes to open source, these are like thousands of people improving it on every single minute step. So the
okay,
net result is so powerful that no organization can actually produce.
okay, okay, understood. So we spoke of business opportunities from GPU, which is the NVIDIA opportunity, to training, which is the ChatGPT, Gemini, what they are chasing there, to inference, and inference is what you are chasing. Who are the other competitors here in the inference layer? So
So I
inference
don't have,
essentially means
yeah, I don't have competition in India. I mean, the inference essentially means you have a use case and you run it for a particular requirement. For example, we built one for one of the state parliaments. We've analyzed 1,000 hours of footage of parliament proceedings. So today, if you want to query women and child welfare, what was the discussion? So it will go through all the 1,000 hours and it will give you snippets of who said what. I mean, so it's and you can get it as text, you can get it as video. So this is when we trained it, the model went through 1,000 hours of footage. But when you ask it this question, it doesn't go back there. It will only go back and pick those snippets from the original thing, but it knows where it is, who has spoken what, everything is known. So that is inference. So training is learning that whole content and everything related to it. Inference is giving you a response.
okay. But there are a lot of companies which are into the enterprise AI domain. Like these are companies which are helping enterprises to adopt AI. Are they not your competitors?
No, I mean, so in fact, a lot of them will have to come. So I am. What is my advantage? Number one, I have 140 petabytes of production data. So companies need not bring data to me. I take AI to them because they're already inside my data center. That's my first confidence building exercise, right? I don't need to really go fetch data. It's with me. All it requires is customer to ask for AI. We are not asking customer for data. We are giving customer AI. That's the first approach. Second approach is um, people are all looking at building models where so their focus is on training. They want to train. We are not really worried about training. We want to infer. So that's where we are trying to get there. This market is not big enough today. It will be big enough in 2 3 years, but the foundation has to be towards inference because I want to go after enterprise inference. There are a lot of people building use cases for consumers and all. We're not going after that also. We are going only towards an enterprise customer. Why believe this play has got a play globally? This is like how Y2K happened for India and the entire software industry happened. I think we can do the same thing with AI because It's no longer you need those scientists and those long hair and all that, because AI does it. I mean, every day we have better tools to do it. So smart kids do it. It's just about the understanding of domain that you need.
Uh, See, like every marketing services agency, digital marketing agency, lot of these digital agencies are now offering these enterprise AI solutions where they will help their clients to adopt AI. So you're saying that the difference between you and them is that you already are at a much deeper
No,
infrastructural
there is.
layer.
It is in simple terms. It is very less. Using AI is very different from building AI. They are all making API calls to ChatGPT, Gemini, Bhashini, or someplace, and then doing a use case. Let's say somebody is doing translation. What do? They take English from you, they'll convert it into Malayalam. But who's actually doing it? It's Google or Bhashini or somebody at the back end. So they are not. I'm not competing with them. This is like a wrapper. This is like phone pay. Is PhonePe doing UPI? That's bullshit. I mean, it's the cheapest application you can build actually, because it's just a wrapper on top of this thing with some frills around it. So Google Pay, PhonePe are not big application building challenges, because the real muscle and the architecture is behind with UPI. So these are all wrapper companies. What we are doing is very different. I mean, we are saying that we build the UPI itself, but we can't build the UPI. We can build a small piece, which is relevant to that particular company. Like, I will not build I mean, I won't go to Dr. Reddy's and say, I'll help you build a drug. No, I'll not do that. I mean, I can't do it. I can tell them that, look, there is a drug making model. How do you want to use it? I can make it useful for you, and I will fine tune it for your requirement.
So you don't do like an API call to a ChatGPT to provide a solution to a client.
No, no, I have a better model. You should use my Aurora. It's got Llama 4.0. It is beautiful. I mean,
So you have used open source to create your own model instead of
yeah.
doing API calls, which increases your margins, or are there other benefits also?
I have no cost in building a model.
Because you're using open source, right?
I just fine tune the model for a specific use case. For example, we took some models, we built a developer assistant, and we use it internally. Some 2,000 developers use across the country. The good thing is, I don't learn from the developers. I don't know what they're doing. It is not connected to internet. It doesn't hallucinate. It only answers whatever that you want to be answered. All my models are not connected to internet. They can't tell you what is today's date, for example, or today's weather, because they have no clue. They've got certain knowledge when they got trained, and they sit in isolation and they answer your queries. And whenever it's upgraded, I upgrade the base model.
Uh, this in a way is like directly competing with the API, right? Like I could either come to you, or I could also directly use an API and build the same solution. Like you gave the example of reading a credit card bill, answering customer query. That could be done through API. Like the credit card bill could be sent to ChatGPT, and the ChatGPT can read the bill and then answer the
Will be
customer
10 times
query.
cheaper.
Sorry.
Will be 10 times cheaper, because
Okay.
the problem with OpenAI is OpenAI has to recover all the billions it spent in training the model. I mean, somebody has to pay for it.
Right.
I don't need to. I have to recover my transactional costs. It's power, GPUs, and a little bit of manpower.
Why do you need to raise 300, $400 million for doing this?
Well, I need GPUs.
Okay. The big cost to do this is the GPU cost. That is, so you are going to build a GPU data center and a GPU cloud.
Yeah, and the dynamics are very different. Actually, what happened is that today, when I'm doing my cloud, I was using certain parameters. Let's say I was using 10 racks. The same thing when I do AI, the 10 racks shrink into one rack. So I was consuming, let's say, 10 kilowatts per rack. Today I need 100 kilowatts per rack. So the dynamics of AI hosting is very, very different. So we thought we were smart, we could get to 100 kilowatt per rack. Now they are demanding 300 kilowatts per rack. This is like a decent enterprise data center in one rack. Um, but by the time next year, this time, we will need 600 kilowatts per rack. So it is like 60 racks becoming one rack. That's the density of power and cooling required. So you need to invest in that. You need to invest in the new age GPUs because you can't buy 10,000 of one. It doesn't work like that in this. You buy what is most modern today. 3 months later, it is actually virtually 3 months. So you buy chunks of 512, 512, 512, and you end up with better and better GPUs. This is like, how we went through 2.5G CDMA to GSM 3G, 4G, like that. That's what is happening, and at a much rapid pace. Um, like this time next year, I think it'll be 6 times faster, more expensive. I don't know how it will go. So you need a lot of money to do it.
Okay. Okay, that's fascinating. So you need money A for GPU, B, you also need to re-architect the the power supply, the cooling designs, all of those need to be made from scratch to accommodate, and also new hardware for the power and the cooling and things like that.
Yeah, I mean, and simple things like I can't host it in my first floor because none of the buildings that exist in this country, I mean, including the data center buildings, can host this kind of density in the first floor itself. So all the data centers that you see multi-story, it can't get to here, get to this place. They'll have to have empty space with one rack. I mean, um, so you have to build it on rock solid ground because they are heavy. So it's the density means more metal, more water, more this thing. So it's a full fledged new investment that goes at the data center layer.
Okay. Uh, do such GPU data centers exist in India?
No, no, none.
None. So
We are
you
the
will.
first ones deploying, liquid cooling in the country. That takes us to 100 kilowatts. We are figuring out how to do 300. We have no clue how we will do 600. We'll get there. It's
Wow.
still.
Okay.
Uh,
So there is. So you also need money for the
Actually, I know I
technology risk.
can't do it in the first floor of my data center.
Ah, okay, okay. So there is a certain amount of technology risk also for which you need money. Like some of your bets may not pay off. You need to experiment with multiple
So
ways
that's one of
to
the
do it.
reasons why you should go after inference because if you go to training, the training guys, the key thing is time to market. How quickly do you want to get the model in the market? So they want the best in class processing so that the processing happens faster. So if you're chasing the training market, your previous generation, like current generation, will be obsolete in 3 months. I mean, they will be demanding the better ones. So, but if you have inference, it doesn't matter where you run. Customer wants the use case to be served. He is not really bothered where you run it. So it will not be idle. We can always recover the money over a period of time.
Okay. This GPU data center, GPU cloud, you are doing only for your own inference services, or are you also planning to offer GPU cloud?
We are doing a lot of startups, especially through India AI. There are some startups building. There are some government agencies building use cases. So first layer is obviously, I mean, people consume GPU as a service and pay on an hourly basis. We were able to bring down the cost significantly. For example, the going rate for H200 GPU was like 500 rupees an hour, and we brought it down to 188 rupees on retail. I mean, so it's like, we were able to do that because of liquid cooling, lot of other aspects to it. But so that's the first layer you sell. So there could be startups building use cases. We are also taking some startups to our customers. So for a very large enterprise group, they have a lot of retail brands. One of the startups built a very nice use case where you can change shirts and you can put new shirt and all that. The beauty is that people would have seen this everywhere, but you will see the good thing about it when you take, let's say, Jensen, who's wearing a leather jacket always. You take off his leather jacket and then put a t-shirt on him, is complex. Okay, so you need to guess how the body is below it. Those are the aspects that the startup brought in. So we are hosting them and we are exposing them to our customers. So there will be independent software guys. There will be our team which will be did, but the whole idea is we get the inference on our infrastructure.
When you collaborate with these startups, you also earn something from the sale? Like there's
No, no,
some
no.
margin. Okay.
No, in India AI case, India AI is giving a subsidy. Startup pays 60%, India AI pays 40%. I
Okay.
mean, it varies from 20. I mean, they pay from the subsidy could be 15% to 40%. I mean, that's India AI's choice. But there are some startups, for example, we are working with a startup to build a trilingual model. Because in India, for us to get language very precise, it shouldn't be English to Malayalam. It should be English to Malayalam plus Hindi plus English, because our languages we mix many more terms. So you need to be able to also talk in the same fashion. It's not that you speak Hindi like Narendra Modi does. I mean, you don't understand few terms. I mean, so we should be able to use some English terms in the middle. I mean, so we are working with a startup to do some trilingual models, where actually we are working on a model with Hindi, English, and Tamil. So there we are co-investing. So our investment is the GPU, their investment is the talent. So various models that we are working on.
Very interesting. What is this India AI thing?
Oh, government has put a budget of about 10,000 crores to build to encourage AI, and they've got 7 pillars in it, including how to safeguard AI, how to share data. One of the things is to provide GPUs at a low subsidized cost to specific projects and government entities and all, so that the adoption increases. So they will spend roughly about 6,000 crores as subsidy. That's a 16,000 crore opportunity. That is, if 6,000 crores is 40% of the subsidy, then the whole market is about 16,000 crores. We are the lowest there. There are 3 companies currently delivering services there. That's a massive opportunity for us. They're also doing subsidy not at 40% everywhere. So the opportunity could be about 20,000 crores for us to work with them.
Wow, massive. Okay, okay. What is the India AI opportunity? Is there like a lot of people feel like India doesn't have its own LLM? Do you think that's a realistic goal to have, or should we focus more on inference?
Um, I think LLM is a one-time thing, and um, so Akshay, actually, we should have it for the sake of having it. The reason being, DeepSeek happened. The beauty about DeepSeek, which China produced, is it thinks very differently from the way ChatGPT thinks. So DeepSeek thinks in stages. ChatGPT thinks at it as a whole. You ask it a physics question, it will refer everything towards biology and all that, and then determine that certain things are not relevant and then present you with an answer. Whereas DeepSeek will analyze your question and come up with. So there is a political pressure to build our own model. See, the beauty is we cannot beat. If you take Meta, Hindi is ridiculously good on Meta. I mean, you should. I mean, you can even it can do all other languages. Maybe not as good as these. One of the problems is this trilingual problem, right? I mean, so but they will get there. You can't beat a Gemini or a Meta in processing languages. They do 200 languages. Um, so India will build it for the sake of building it. But what is useful for India? For example, we are training a model which is a financial professional assistant. This is trained as a CA. So we trained 8 textbooks of CA, all the tax cases from 1969 to December of last year. We trained, that is interpretation of all these laws. and GST and all these laws and stuff like that. So, what is it? It gives you precise accounting answers which are relevant to India. It doesn't give generalized accounting answers. There is a lot of benefit in doing domain specific, India specific models, which will be much smaller. So, our model is roughly about 8 billion parameters. It is not a large language model. It is, we are trying to make it work on a regular server. So a lot of these things will be more popular in the long run, but I think getting an LLM is a pure political India ego agenda. And
Okay.
yeah, because you
Okay.
can't beat these larger models. It's not possible.
Mm.
Like even if somebody produces, they'll produce a model. To give you this thing, there is a 605 billion parameter DeepSeek model, and when you host, I mean, it doesn't run in most systems. I mean, when you host it in our systems, I mean, you ask, I mean, it's the way it responds is totally different. Our best large language model will be 8-10 billion model.
Uh,
We are in a
what
way
is
reinventing.
okay? What is the definition of a small language model and a large language model?
There's
Just
no firm
number of.
thing, but typically, if you have a large language model, you need large amount of memory on the GPU. If even that is not enough, you have to network a lot of memories of GPUs to actually be able to load. Like the chat DeepSeek 605 doesn't load on the largest of the GPUs, one number. You need a minimum of 30 numbers to load it, and just to load. A small language model is the amount of memory it will take. In a way, you can say that 8 billion parameters and less is becomes small language model, or even much less, so that it can load in small amount of memory on a GPU.
Okay. So typically, a small language model would be like the CA that you created, the CA model, which is trained on a limited data set, and the 8 million parameter means that is referring to the amount of data it is trained on. So 8 million means it is a smaller
Number of
set of data.
parameters that it will inference on. 8 billion parameters it will inference on. So what do? We take an open source model, we retain the language capability and reasoning capability, and ask it to forget every other knowledge it has. That is, I don't want your biology, nothing. Only your reasoning capability and language capability. Then I give this domain specific information. This process is called fine tuning. So we strip all the other unwanted stuff and we add what we want. So it will behave only like this. So you can't ask it like, how do you get rain? I mean, it can't answer. I mean, it doesn't have the knowledge. Original model had it, we stripped it out because it's open source.
Okay, okay. And like typically, enterprise chatbots are uh, they're not really small language model, right? They would be using some sort of an API call, but there would be some amount of guardrails built in so that it is only giving answers which are taken from the enterprise information set.
So that's the game. So why this domain specificity is important is in an enterprise or a professional use, the response has to be precise. You can't guess. It's not like ChatGPT. You can't say if it is 2 plus 2, it is 4. You cannot say it could be 4, 5, 6. That's not a option there. Like you do it in medical, you do it in, so whenever it becomes domain specific, the accuracy has to be near 100%, and you cannot afford for any hallucination. It cannot think that, okay, I thought, I mean, this is what it is. So what happens in ChatGPT is if it doesn't understand, it will assume and respond. In an enterprise case, you cannot assume. You need to curtail that.
Hmm. Okay, okay, understood. So essentially, at scale, every enterprise will need a small language model.
On multiple, because you have some customer use cases. Like we are doing for a electronics factory in Bangalore. We are doing a model for finding out faults in PCBs. So it's normally a vision language model where you give pictures and you generate pictures. I mean, we're using the same thing, but here we're telling, okay, only look at this, only these are the faults. I mean, this is what you do. I mean, so it could be every enterprise will have 5, 10. As we mature, we'll have more use cases.
And this really uh, and this really is the India opportunity to build small language models for the world.
Globally, it is 100 times bigger opportunity than training. Because for consumer, you will always build one model which is smarter and smarter and smarter. But in enterprise, you will build one for manufacturing, one for accounting, one for HR, one. I mean, like it'll go on and on and on.
Okay, fascinating. Okay, so let me end now. I have taken a lot more time than we had on your calendar. But let me just ask you, do you want to leave our audience with any advice, people who are aspiring to be builders of the future? Any advice you'd like to leave them with?
Yeah, I mean, I think it's the beautiful thing is that I mean, in my lifetime, Akshay, actually, I have come from a time when we had to wait for 5 years to get a telephone line to an excess of communication where you could actually make a video call on the move, right? I mean, if you can extrapolate this kind of change for next 20 years, you could imagine what could happen, and that's what AI is going to fuel. So I think everybody should go and do something with AI. The least we should do is not, I mean, use it. The best we should do is leverage it to create something new, and we cannot miss this bus. There is no option there.
Thank you so much for your time, Raj.
Thank you, Akshay.